Okay, here's the calculator permitted portion of the exam. We start off with solving equations by a calculator. This is a skill you need in next year. You should go fairly quickly. If you're slow on the keystrokes, it'll take you more time than it really needs. So let's see, we start off with find all solutions on this trig equation. I have a calculator here. I'm going to use the older calculator because the display is a little bit larger. For trig problems, you need to be in radian mode. If the problem doesn't say degrees, it has to be in radian mode. So check that first, radian mode, not degree mode. The second thing you want to do is enter the equation in as y1 on the graphing calculator. So sine of x, take away the x squared and add the 3, okay? Notice that it does equal 0, so when we get the graph, we'll be looking for the zeros. Zoom 6 is the best way to do that. I see 2 zeros. No solution would be wrong. That only has one solution. That's wrong. There's 2 solutions here and 2 solutions here. It's either going to be choice C or E. We find one of them. This solution looks like it's between 1 and 3. So second trace allows me to find those zeros, and I need to enter in the numbers on either side of the 0, like 1 and 3. It doesn't have to be 1 and 3, it could be 0 and 7. But I'm just going to go 1, enter, 3, enter, and then immediately enter again. If I see the word 0, that's the solution, 1.979. This is choice E is the answer. I don't need to chase down the second solution. If I wanted to, I could, but I don't have to for this problem. Okay, number 2. Clear this off. I want to move everything to one side. So this has got to equal 0 because we're looking for the zeros. So I'm going to got the natural log of x, but now I have to add the x, right, to make it 0. So plus x. And again, zoom 6 is the graph. I see the graph go tootling up like that. There's a 0 there somewhere between 0 and 1, it looks like. So second trace 0. We'll go between 0 and 1 and guess, and there it is. It's 0.567. That's the answer to this problem. So again, fairly quick on these problems. Now, if you look at the graph and it doesn't hit the x-axis, then the equation would have no solutions. If it hits it in more than one, it might have 2 solutions. Okay, so let's look at number 3. All the solutions to this one. So again, we're going to go to our calculator. We want to move everything to one side. So think of, I'm going to type in the 2 to the x minus the x cubed is equal to 0, because that's what I want to do. I want to find the zeros of the function. So y is equal to 2 raised to the x power, and then minus the x raised to the 3rd power. Okay, so here's the graph, zoom 6. So I certainly see a 0 there somewhere between, it looks like 1 and 2, but then the graph comes shooting up here way off to the right. So there's another 0 over here. If I open the window up just a little bit, right now the max x is at 10. If I made that 15, just to verify, yeah, there's another 0 over there to the right. So I'm looking for one that has a couple of zeros. This one looks like 1 point something. Probably 1.37, and then another one at 9.9. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That looks really close to 9.9. 13, 11, 12, 13. I don't see another crossing at 13, so it's probably not E. If I open up my window again a little bit more, maybe make the x max 20, you can see that there is no other crossing other than these 2. So the only choice that's reasonable is this one here. I don't even have to find the zeros. If I wanted to, I could, just to make my mind feel a little bit better. This one looks like it's between 1 and 2. So second trace 0, okay, left bound 1, right bound 2, and then guess. And there it is, 1.373. That corresponds to that smaller of the 2 zeros. Okay, limit problems. So we were doing limit problems in the last unit. So let's see, we're going to have this ratio of the log of x minus the log of 4 over x minus 4 and see what happens when x gets close to 4. So again, a calculator problem. For here, we're going to throw in the fraction, right? There's a way of doing that if you want to. If not, you can just use parentheses around the numerator and parentheses around the denominator. We have the natural log of x. Take away the natural log of 4. So that's what's up top. And on the bottom, we just have x minus 4. X minus 4. Now, we could look at the picture. So zoom 6, here's the graph. It doesn't show us much, right? We're real hard to discern what's going on. We're not trying to solve an equation. We're trying to figure out what happens to this when x gets close to 4. If we hit trace and we put 4 in, we see the function's actually undefined. There is no value at 4 because this would be 0 over 0, right? So it's undefined. There's a hole in the graph. But what we want to know is what happens when we get close to 4. So we could hit trace and do 4.001. That's pretty close to 4. There's the y value. Okay. Or we can go on the other side of 4, like 3.999. 3.999, and that's the y value. In both cases, the y value is getting close to a quarter. That's what we got, 0.25. Now, frankly, oftentimes the pictures of these things become very awkward, and the trace only works if you're in the window. And fortunately, 4 is in the window in here. But we can still do this from the home screen without a picture. So just go back to the home screen and call up y1. It's under the vars menu, the y-vars function. There's y1. And then we're using function notation here. So parentheses, y1 of 3.999. And again, you see that value. Or y1 of 4.001. Okay, again, you see the value close to a quarter. Either way you do it, graphing or from the home screen. I sort of prefer the home screen for mine. That's the way I've done it for all the time for these limit problems. Okay, let's go to number 5. Again, we'll throw this in here. We have the tangent. This one, I won't do the fraction bar. I'll just do the tangent of x minus the tangent of 5, sort of in parentheses here. So tan of x minus the tan of 5, close the numerator, divide that by x minus 5. X minus 5. Now, another comment here. Be smarter than the equipment you operate. In this mode, the function actually scrolled off, and I can't see the entire thing. You can change that. If you go to mode and go to classic right here, and put it in classic mode, then the function will not scroll off the edge if it's long. So now I can see the tangent of x minus the tangent of 5 divided by x minus 5. So it's just a trick you could use so you can see you put the entire thing in here. Vars, y vars, function y1. And again, I'm putting numbers in close to 5, like 5.001. That's pretty close to 5. Or 4.999, right? 4.999. Okay, and I'm getting around 12.42-ish. If I were to get closer, I could get even closer to this value. So, you know, if I threw in a couple of other 9s, like that, 12.428, so now we're getting it. Or on the other side, 5.00001. So really close to 5. And again, I'm seeing this 12.428. That's the answer. Okay. So most of these problems are less than a minute apiece. So you key them in, find the 0, or for the limit problems, put a number in close to the limiting value. Okay. Here's another limit problem. This one, we have a limit of this expression when x gets really large. So x is not going to go to a number, but x goes 10, 20, 30, 50, 100. So we can approach it the same way. We throw in the expression. We have -3 raised to the minus x divided by 4 power. Again, I'm in classic mode, so this just sort of runs it out all in one line. It doesn't see the exponent raised up. That's the math print mode. And then add 5. Okay, here's the graph, zoom 6. it looks like there's a horizontal asymptote. This is what's asking what happens when x gets large. So if I trace, and if I try putting 9 in, you see I'm getting close to 5. If I try putting 20 in, it won't do it. It says there's an error because the window didn't go out to 20. So, I could change the window up and make this go out to 20. And then there's the graph, and certainly it looks like we're going out that way. So trace, and I'll put in 19 this time. Yeah, we see we're getting close to 5. Again, you can avoid the window issue if you'd like by just going to the home screen, vars, y vars, function y1, and now you put in whatever number you want. Here's 30. Okay, and here's if you put in 50. So it looks like the further out we go, whoops, clear, put in 50 in the parentheses. Okay, and we're getting closer and closer to 5. That's the limiting value down here. Number 7 is not a calculator problem. It doesn't say calc. All of these said calc. Number 7 is, it just says the water depth at a particular tidal recording station is given by this equation. Which of the following most closely approximates the graph? You could try putting in your calculator as long as you adjust the window correctly, that would be fine. But here, we should be able to look at these and make a reasonable guess. This looks like a sine wave that's upside down. So this would be a sine wave that's right side up. That's not it. This is a sine wave that's upside down. So this is going to be the correct choice. A is the answer. If we look at the other two, this looks like a cosine wave, right? Starting high and then going down. And this is an upside down cosine wave. So the correct choice is, in fact, A. If we use the calculator on this, it will take a little bit more time. You're permitted to do that. So we would go in and throw in the equation. We have minus 4 sine. Now, there's a pi and a t, but we're not going to use t. We're on a calculator that's using x's and y's. So it doesn't say d, it says y. And it's not going to say t, it's going to say x divided by 12 plus 24. Now, in the standard window, this is what I see, zoom 6, I don't see it. So I need to be conscious that the window here in all of these is running from 0 to 24 by 6s and 20 to 28 by 2s. So if I adjust my window to match that, then I'll see the right picture. So the window is running from 0 to 24, 0 to 24, and the scale is every 6, 6, 12, 18, okay, 6. And the min is 20, and the max is 28, and the scale there is every 2. Here's the graph, and now you see that picture. Okay, so it can be done with the calculator if you wanted to. Okay, I'll stop here. One other comment on this particular problem. You might be asked, to find the value if t is equal to 7, but that requires a calculator. I don't know what the sine of 7 pi over 12 is. That's not a standard angle. So if that were the case and you had the function sitting in here, you could just go to the home screen, vars, y vars, function y1, and now you can put in whatever value you want, like 7. So the water depth would be 20 feet. If we put in, just by looking at the picture, if we put in 18, the water depth should be 28. And it is. So if we put in 18, we really would not need a calculator for this. We get 28, because 18 over 12, 18 pi over 12, that's going to be a standard angle, and you can do that with the unit circle. Okay, let me stop this here.